Hello everybody and welcome back to another visual pattern challenge. Here's our pattern today. We've got step 1, step 2, step 3, and your challenge would be to predict the number of blocks in step 4. If you can do that, can you predict the number in step 43? And can you write an equation that could be used to predict the number of blocks in any step at all? That's the challenge. If you'd like to take it, pause the video, see what you can do. All right, so just getting some visual intuition about this. I'm seeing, well, these blocks are sort of presented in this three-dimensional method, but I don't think this is a big cubic function because there's only one layer of blocks, and they're sort of in rectangles with a little bite taken out of them. Looks like one block missing from every rectangle, and the rectangles are getting wider and getting longer in each step. So I think this is going to be quadratic. The area formula for the area of a rectangle is a length times width, so you're going to get something squared in here. That's my thought. Let's see if we can look at the pattern just to predict step 4 without analyzing the numbers first. So this is a 3 by 2 rectangle with one missing. Then we have 4 by 3, 5 by 4. So I would expect this to be 6 by 5 rectangle with one block missing. So we'll subtract a block. And that's 6 times 5 is 30 minus 1 would be 29. So I'm thinking in step 4, there are going to be 29 blocks. Let's take a minute to analyze the numbers and see if our hunch about the quadratic is right. So I'll make a chart with the step number and the number of blocks in each step. So here we have 5 in step 1. And in step 2, well, this is 4 by 3, so it's 11, 12 minus 1. And in step 3, this is 5 by 4, that's 20 minus 1 would be 19. And in step 4, we're predicting 29. So to analyze these numbers, we'll take the difference between each step. 11 minus 5 is 6, 19 minus 11 is 8, and 20 minus 19 is 10. Not a constant, so it's not a linear pattern. Let's see if it's a quadratic by taking the difference of the differences. 8 minus 6 is 2, and 10 minus 8 is 2. Aha! When you get a constant in the second order differences, that means it's a quadratic. This 2 means that the coefficient is 1. So it's just going to be an x squared as our leading term. You take this difference of the difference number, if it's a constant, and divide it by 2 to get the coefficient of the x squared term. Okay, so there it is. Sometimes I approach this by saying look for x, the step number squared in each step, and then block out the rest of it and see what's happening. I think I'm going to take a slightly different approach because these squares jump out at me. Like this is a 2 by 2 square, this is a 3 by 3 square, and this is a 4 by 4 square. Those are all 1 greater than the step number. So that square part I could write as the step number, x will be the step number, plus 1, so 1 greater than the step number, and then square that. So in step 1, we'd have 1 plus 1, 2 squared. That's a 2 by 2 square. Now there's something else going on here, right? There's 1 block left over here, and then 2 blocks, and then 3 blocks. That's just the step number, and we represent the step number with x. So I can just add x. And this should be the whole equation. In fact, you could leave it just like that if you want to. It really represents what we can see here pretty handily. I think I'm going to FOIL this out and combine like terms to simplify it a little bit though. So foiling this, I would get x squared plus 2x plus 1, and then we have this plus x. And combining these like terms, I would get x squared plus 3x plus 1. Okay. So that's the equation. Let's just test this, make sure it's working. In step 1, it would be 1 squared plus 3 times 1 plus 1. So that's 1 plus 3 plus 1. Yeah, that's 5. How about in step 2, 2 squared plus 3 times 2 plus 1. So 2 squared is 4, plus 3 times 2 is 6, so it's 10 plus 1 is 11. Yeah, that's working. And if you want to, you can go ahead and check that with step 3. I'm confident in this equation, so I'm just going to enter it here as our answer. Y equals x squared plus 3x plus 1. Now, to get the number of blocks in step 43, all we've got to do is plug in 43 for x. So y equals 43 squared plus 3 times 43 plus 1. And 43 squared is 1849. 43 times 3, well, 3 times 40 is 120, 3 times 3 is 9, so it's 129, and then plus 1. So we're going to have, that's 18, 19, and that's a 7, and a 9, and a 1,979 blocks in step 43. Well, is that what you got? Maybe you want to check my math here, make sure I didn't make a mistake. Did you get 29 in step number 4? Let me know. Thanks, everybody.